Maybe to describe the philosophy of this workshop, I should go back to there was a play by Anna Devere Smith where she quoted, or actually acted out, of course, and an astronomer from MIT, a professor of astronomy from MIT, describing how you try to look at very distant objects, and he said, the main idea is, the big thing you do is you have to create a mirror as large as possible, and it doesn't matter, there'll always be imperfections, but if you have a large enough mirror, then you can really, tell very small differences apart. And in this case, when you're trying to understand something difficult, it's really helpful to have a very large numbers of points of view juxtaposed in a way where there's a lot of discussion. And so that brings me to the final point about this, which is that one of the rules that we use for some workshops here at the Simons Institute is discussion trumps schedule. Now,
I was thinking when I was looking at the watch, that's your point.
Yes. So unfortunately, in this case, there was a lot to cover. There are many speakers. The schedule is more full than we'd have liked. But even so, we've left, a third of the time, available for speakers for discussion. So feel free to ask questions also during the talks. They'll be moderated by session chairs. So if there's too many questions, we'll try to tamp it down. But discussions are we have a great set of speakers, but also the audience is an integral part of this workshop. Okay, and let's see. Two more points before I stop. There's a session on Friday afternoon for contributed talks. So if you'd like to contribute a talk, there'll be a way to do that on the workshop webpage by this evening. So and these will be short talks between 5 and 20 minutes. So okay, and then finally, I should say that it seems like there is finally the beginnings of COVID in there. So if you wish to, there are masks at the front desk if you want to mask up. Okay. So let's start with the first talk by Yin Tat Lee at Microsoft Research. So I know Yin Tat for a long time as as one of the brilliant leading algorithms designers, and but over the last few years, he's transitioned to machine learning, showing some prescience in doing so. And he'll tell us, he was on the Sparks paper, and he'll also tell us about smaller models that he's been training that do code generation. Yin Tat.
Can you hear? Yeah, I have been a long-time supporter for Simons. You can see this is a t-shirt many years ago. And usually I come here as an expert. For example, I come here as a mathematician talking about log concave distribution, or I come here as an optimizer talking about linear program. But this time I really come to talk about something I don't really understand. And so I'm really privileged about this. Yeah, and I start the talk with this poll just to see how many people have been using GPT-4, and yeah, I guess almost everyone is using GPT-4 now. So I guess first part of talk is kind of unnecessary. This talk has two parts. One part is the Sparks talk you must ask me to present, and the other part is a smaller model we are trying to train. Yeah, so I guess, where is my mouse? So this is the first part is just some early experiment with GPT-4, and I won't write my conclusion here, but I guess everyone here, almost everyone here, already using GPT-4, so you would know what is my conclusion. But essentially, we really like GPT-4, so we asked a lateral question: can we get a GPT-4-ish stuff, but much smaller and cheaper to train? And turns out you can get a pretty good coding model from scratch using just $3,000. This is not a fine-tuned model, but it's trained from scratch. Yeah, this two picture is created by AI. This is GPT-4. Pretty nice. And both talk all the co-author is from Microsoft. For the first one. Oh, by the way, if you have any question about anything, just stop me. Feel free to stop me. So we are really grateful for OpenAI giving us access to GPT-4. The version we have access is some earlier version. We done our experiment around October last year. This is a funny time because this is before the announcement of GPT 3.5. So when we are testing 4, we don't even know that exists a 3.5, the ChatGPT. And so at that time, it both our mind even greater because the previous version of GPT is free and that version is not that good. So this is a really huge jump for us. And the model we assess at that time is still being training, and it has less insertion fine-tune. So it will answer any question you ask, and it is test-only model. So at that time, they haven't fine-tuned with the image. And at that time, before this, the only model we know is GPT-3. So, and for us, we think GPT-3 is like a model just can copy and paste some style or something. So we start with a very mild goal. We want to see, can we at least show some example? GPT-4 is doing something beyond copy and paste. That is what we think at that time. And it completely blows my mind. But I guess the main question is, how can we tell whether a model is copy and paste? We don't have very scientific approach. So what we do is we just ask some very creative questions. We try to come up with something we believe not on the internet. Although after our paper is online, many people point out many questions we ask is on the internet. So, but this is a tough question. So we start with some task that is unfair to GPT-4. Remember, the model we test is a test-only model. It only with tests, so you can think it's a 5 people for his whole life. And then we ask it, can GPT-4 draw? So this, can anyone guess what is this picture? This is a picture by some 5 people. Yeah, this is a cat. So I'm just giving this as a baseline what a human can do if he never can see. And so we asked GPT-4 draw a unicorn. Probably many of you have already seen that unicorn. So we asked GPT-4 to draw a unicorn, and this is what we get. Although this doesn't look nice, but this is still crazy. Remember, it only with tests, so it learned about latex with the whole archive. It have with many Wikipedia articles. It knows what is a unicorn. Maybe it knows unicorn have 4 legs and something, but maybe he don't know the head should be above the body where that knowledge come from, or maybe he doesn't know. Maybe the corn should be there instead of there, and also remember this is drawn by Taxi, and if you try to draw a picture on Taxi, it's very difficult. You need to specify each coordinate of each circle, where is that. So even able to draw 2 circles touching is already some math inside. But it turns out can draw a beautiful-ish unicorn. Yeah, I think I should try to draw myself. I don't think I can draw that good without trial and error. Any question about unicorn? Something is not touching. Oh, yeah. Honestly, I don't know what is unicorn look like. Maybe my son know better. We try many things. Oh yeah, in fact, the first thing we try is the Pokemon. But for copyright reason, we are not posting. But it look like a Pokemon, Pikachu.
There's a standard C10 library that has animals in text.
Yeah. We noticed that after the paper is online. But at least this look horrible. So I think it's more realistically not copying because it is horrible. But yeah, then after we see that, then we are debating with my colleague. We are debating with colleague. Is that copying from the internet or it joy on its own? And for myself, I'm pretty sure this is real because it is horrible. But some colleagues don't believe. So then we need to test: is this copy? So the thing we test is this. How about if we look at the taxi code in January, we remove all command. The command is very good. Where is the head? Where is the body? So it's a good code. We remove all command. We randomly permute some coordinate just to make sure it's not copying. And we remove the horn and ask him to give the perturbed code to GPT and ask it to draw back the horn. And here is, you see the leg is moved around, so this is not the original unicorn. And it's able to draw the horn. So at least so you can think it not only able to draw a unicorn, it also able to understand a unicorn. We also do other tests, like we give it some picture and ask him what is that. And sometimes it can do and sometimes it can't. But if the diagram is simple enough, usually it can. And so I think this is a pretty good evidence. It's not just copying from the internet. And remember, when we are testing the GPT-4, it is still ongoing training. So we can test it again and again to see how the unicorn change over time. If it is changing, then we know it is probably not copying. So this is 3 unicorn 2 weeks apart. You can see there is the magic of training is happening. The unicorn becomes better and better, and this is look really, really nice. Although the middle one look like a pig.
Wait, why did it become better? Or why
It is doing training.
Oh, because of chain of thought.
No. It is.
Oh,
The model is.
it took the previous one as input. You're saying.
No. The model is still ongoing training.
Oh, training.
Yeah,
Okay,
yeah.
Thank you.
Yeah.
What kind of training is it? Just additional like next token prediction, or was it?
Yeah. I don't exactly know what they are doing. They either doing the pre-training, namely reading the whole internet, or they are doing fine-tuning some human instruction and answer just to make sure it understands instruction.
Were they using any of the interactions the beta testers were?
Yeah. They are doing those things, but I don't know at that time what they are doing.
I think maybe he's asking is, did they use your unicorn instruction?
No, they don't know about unicorn
Instruction. Yeah.
1 week before we put the paper online. Otherwise, it's not fair. But then you may ask, what is the unicorn look like? This is October, November. And after our paper online, there is different website about hourly update of unicorn and a daily update of unicorn. I cannot open the hourly update because when I open it, my browser will crash. There is too many images. So this is a daily update of unicorn. It is horrible. But roughly speaking, the reason is after the model is perfect, they need to compress it down to make it easier to run. And after compressing, then the unicorn becomes more like human drawing. Oh yeah, and certainly we test if we can draw 2D, how about 3D? This is not a precise problem. The problem is longer, but we just try to come up some combination that cannot be on the internet. some floating island, waterfall, bridge, castle, flying dragon, and island and Olympic ring. Anyone see the Olympic ring? Yeah, there's some color of Olympic there. And yeah, and
This is in some 3D scripting language?
yeah, I asked him to write HTML. I didn't know HTML can do this before, but apparently you can do anything in HTML now. So at least for this part of the experiment, I feel AI is already kind of human-ish or beyond human, depends on who you are. At least for me, I cannot draw anything that is beyond me. And also remember, usually when human draw, we draw, especially for doing taxi, we type some code and then see the result and then modify your code and see the result. But the AI can never see the result, so I can see the result and pick a good one. But at least it's way more difficult and unfair. Yeah, so this is drawing. But the real application of GPT-4 is coding. So we do some very simple tests. So in the LeetCode website, they have some interview exercise for people doing for different company interview. So we give him an Amazon interview. This is a 2-hour interview. It done in 4 minutes. It takes 4 minutes because we need to copy and paste to the AI the question, and it get 100% correct. But this is not a good test because we don't really know whether those are just standard interview tests and he can copy from the internet. So can we come up with something that you cannot copy? So what I do is this: I just come up with some random game and ask it to do. I try to make it more Microsoft. Write me a physics game using JavaScript. It's a 3D game. The arena is a Microsoft logo, and from time to time there's a ball dropped to the arena. The color of the ball is one of the color of Microsoft logo, and then you start with 5 life and 0 score. If the ball hit the arena, the ball will disappear. If the color doesn't match, you lose 1 life. If it matches, you get 10 score, and you can remove a ball by kicking it. And still, if game over, write in HTML. So this, I don't know for professional programmer how long it takes to do this. I'm not a professional programmer, but you can play the game here. Wait, playing this game is very important. Let me. Yeah, so this is the game. You can see I can barely play a game. This game will go faster and faster. So this is a reasonable game to play. You can play offline, but eventually you will lose because it's too fast. But this game have something like 500 lines of code. You can look at the source code yourself. I also write down the precise prompt I give in the source code, so you can just take a look.
So I have a question. So that's interesting. The way you specified the game, you said what you want to happen in it, right?
Yeah.
But suppose you wanted to say something like, I want to come up with a game that would test whether a multitasking ability.
Wow.
So in other words, something that has 2 tasks at least, and the people who are better at doing, 2 tasks.
Yeah, you okay?
perform
You
better. So I mean, it would be like more of an idea rather than like step by step what you want to happen in the game.
yeah. If you ask him something more open-ended, then you will end up getting some more standard result.
Standard.
Namely, if there is some game in the internet satisfy that, then he will start split out those things. That's why we try to not open-ended. Also, when it is too open-ended, usually you get very simple result.
Right.
But our goal is to look more impressive.
But in terms of the fact that you are arguing that this is how you're trying to measure whether this is as intelligent as
Yeah.
what a programmer would do. I don't know what a programmer.
Oh yeah, no. I think for open-ended, GPT-4 is less good than human by a large margin. It is good at emulating something on the internet, but it doesn't really. I don't know.
No, I'm just curious about about asking you. Forget GPT-4. Is that a reasonable proxy, in your opinion, to what you would expect an intelligent?
Yeah, no, I agree for human. Certainly, a more open-ended thing that he can really showcase what is doing.
I have another question. Because this kind of test you're doing seems like something where you could just get like some collider from the internet on how to do a ball from another side of the internet and mix it all together to get this game.
Yeah.
But did you try something like more math style for, like, example, competitive programming questions that are out in the internet?
Oh yeah, we did some. Oh, at that time we take 100 latest legal question and ask to GPT-4, and the performance is about the human level.
But the questions that you got were not.
Yeah, and so Nico every week have a competition.
Okay.
We assume those are new questions.
Yeah.
Yeah. I think. Yeah. So far so good. GPT-4 is pretty good. So now I start give something that is horrible for GPT like math. So at least we still have some edge. So my mouse is gone. Okay. My computer is freezing. Okay. So what is the best way to test human about math is doing a one-to-one interview. So in our team we have seems my slides is not. I already closed the game. Maybe it's the website. Maybe I closed everything. Wow, there's some delay. Okay, wait. Interesting. My keyboard is not working, but my mouse is working. It's fine. So one best way to test human in math is do one-on-one interview. And in our team, there is a famous mathematician Roland there. And so we asked him to interview the GPT-4. He is also an author of both of the paper. So he tried to interview GPT-4 as it is a new coming master student to see if he would hire that student. So this is what he asked. Can you remind me what is k-set form? And yeah, this is simple. It's just a definition. And then can you remind me what is the obvious way to solve k-set? This is also simple. It's just brute force. And then, but to really test if someone understands math, then we want to combine between different concepts in math. So we do this. So for every k-set, he defines some graph associated with the k-set, something like each variable corresponding to a vertex in the graph. And then he asks, what if the graph is disconnected? How fast you can solve k-set? According to Roland, he thinks those questions is new. He come up with himself, so he don't believe it's on the internet. I don't know about this, but at least this is the question. And then GPT-4 answer correctly. You can, if the graph is disconnected, they are just two independent copy of k-set. You can solve them separately. So far so good. And then how about if the graph is one connected? If you remove one edge, it will become disconnected. How can you solve it? And GPT-4 is also correct. He say you just put force on that edge and then solve the problem separately on both. So those are still correct. And according to Roland, it passed the test for master student. But then the whole thing is, but then if if the interview is 5 minutes, GPT-4 can pass it. But if the interview is 1 hour, then it go horribly wrong. After you continue to ask, you start realize he may not even understand what is the question, have some completely nonsense output. We just give one complete nonsense here. This is a simple question just to make sure everyone understands the question. We have an equation 7 times 4 plus 8 times 8 is 92. Can you change one number such that the output is 106? So this is, I don't know which level is this, maybe middle school. And then let's see, and in case you cannot solve, the answer is you can change 4 to 6 there. And the way you try to solve it is you look at the difference and try to come up with something. And then, but one thing GPT-4 is bad at is, remember what those LLM is doing? It is trying to predicting letter by letter, so it outputting something. So it doesn't really do any planning, or it cannot go back to fix its mistake. So this question is a little bit tricky. Maybe the first thing you try may not work. So it needs some planning or some try and error. And this is what GPT-4 give. It usually start with some sentence that is meaningless. Like there is few possible way. At that time, it like to start with some meaningless sentence. Like there is multiple way to solve a problem, and then it starts writing down the answer immediately. Imagine you are the GPT-4 model. You are generating this sentence. This has nothing to do with the question. It's just repeating something. And then the first number is generating is already affect the answer. If it white lie here, then the rest of the equation must be correct. Otherwise, it cannot go back. Unfortunately, he generated the first number incorrectly, and then he loses the game. He just continues trying to complete his sentence. Okay, 9 blah 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 is 106, and why? Because if you change 7 to 9 and then you try to explain it mistake. And
for this one, like if you do this now, does it work? I mean,
I never tried.
So when your paper came out, like half of the things that like didn't work in the paper were fixed within 2 weeks.
Oh, you
Literally like 2 weeks after.
Oh,
all of the things that were like.
Okay, I didn't know.
I think
But some of the example in the slides is not on the paper. Does that work?
You say, okay, so the difficulty here, the problem it has is with planning. So I find it a little puzzling that it would have trouble with planning here. But when you talk about satisfiability and the bipartite graph and it's disconnected, that it can answer that question without planning, or
I did
speak to your insights into that.
I feel if the problem, the first thought is the answer, then it is easier for GPT-4. But it is very puzzling for coding how you can write everything correctly without planning.
Yin Tat, I just tried it with the code interpreter plugin. It got it.
Oh, nice.
So, could this be another example of the famous Moravec's paradox, which says that the hard things are easy and the easy things are hard? It's very hard to think in very high dimension. The same way, it's very hard to know what is on the internet, right? So, in a lot of your examples, you say, well, I don't know if it's on the internet or not. And it seems like you actually do want to figure this out, to really know what is actually generated, what is synthesized, and what is coupled together in this postmodernist hodgepodge from sources that are out there.
Yeah, no.
Any ways of figuring this out?
One way we try to do is do our experiment more interactively, because when we are playing with the model, then it blow up the capacity, and when we are playing with it, we realize it seems to understand something. But if you play long enough, it sometimes starts generating some error, and then everything after is nonsense.
So it's basically like final exams in some for our students. They do very well in the final exam, and then you call them into your office and you realize that they don't understand anything.
Yeah, yeah, you can think it that way.
How do you know that it's not actually doing anything in that initial prefix? So, for example, you try changing some of the numbers, seeing if like the output logic change.
I didn't know what's going on with this as well, but yeah, but I think the model have true difficulty of any problem require more planning. At least this is consistent at that time, but maybe now it's better.
I mean, you're using the term planning, but I think a much simpler thing is just a calculator, or just
Oh,
the
yeah,
ability
yeah.
to execute some simple.
Oh yeah, maybe a better.
Yeah.
We try a more funny experiment like this. We ask it to generate a story. The first word is the reverse of the last word. Then you really panic, and we can never make it work at that time. I don't know now.
It would probably need a scratch space.
Yeah.
I just tried it. It doesn't work without the code interpreter. So what you're saying you did is you actually used.
So actually, Ernie Davis and I have a paper on the archive from just last week where we're trying a bunch of examples with code interpreter and the Wolfram Alpha plugins. And we see very, very clearly that it can solve way more math problems with the plugins than without them. It's like it's night and day.
Yeah. I also.
So is it possible that what's happening? So at each step, it's creating a distribution and sampling from that to the next token. Is it possible that's what's happening here? Or is it just randomly, accidentally generated a 9, and then it has to justify its own mistake because it can't go back? Like there's an error of like it not being deterministic more than anything else?
Oh yeah, you can think it that way. For example, for many famous benchmark like coding, math, if you allow it to generate multiple answers and pick the best one or ask it to choose that, then you will get way better.
But I think the point is here that if the only solution is to change the 4 to a 6, then it never should have assigned any probability to 9. Right?
Well, that's what I mean. Is it possible that this is a sort of the error is coming from the fact that it's not deterministic when it's solving this, more than it's not planning?
But when we generate, we usually choose temperature is 0, so it's deterministic-ish.
So in all this, you're starting with this question. Is it remembering things on the internet, or is it is it actually understanding that? Does that mean that you're starting with this that the model is large enough that it could, in principle, remember the entire internet? Is that your
conclusion? No, I don't want to make any conclusion.
No, but just in terms. No. But what I'm saying is, just in terms of the size of the model, is the assumption that you can compress the internet down to all its essential content, and the model is big enough to handle that. That's the starting point, right? For what you're.
Starting for what?
That's the base assumption here, that in fact the model is compressing the internet down to that it's big enough that it contains all the information.
Yeah, certainly. Yeah. Oh yeah, in fact, one thing I really like about the model is it knows who is Yin Tat Lee.
It knows what?
Who is Yin Tat Lee?
But I mean, if you don't give it a calculator, then I would say like its ability to do arithmetic is about like what a person's would be while they're dreaming. Like it can't do 2-digit addition, right? But
No, this is not that. This is not about calculating. This is about it is trying to complete the sentence that it look like correct. If you change this to any number, this will reflect here.
Okay, but then
this is not a
mistake at the bottom. So.
Oh no, he always pretend he is correct.
Yeah. Okay,
so it's not
that's a separate thing. That it doesn't know what it doesn't know.
Yeah. I think the current version of GPT-4 is opposite. He always apologizes even if you point out something he is correct to be incorrect. But this version is a stubborn version. Oh yeah.
So what if you just let it try a couple of times, and then it's like it doesn't appreciate that the last
thing is a hard rule. Like you have to modify exactly one integer, that's fine. It did that. So it doesn't appreciate that it needs to check the work.
Yeah. In general, if the problem have only one answer, then it is not too good.
Actually, going further to what you said, in my case, when I tried it, it attempted a couple times, the logic was right, but it was getting non-integer solutions, and it said, therefore, with the provided identity and constraints, it is not possible. So it has, it's kind of funny.
Yeah, so I guess we should wait for 5.
And when is that coming?
Well, you should ask him.
Yes.
I think he is not allowed to say those things.
If I knew, or if anyone knew, then I wouldn't be allowed to. But I don't think anyone knows. But no, I mean, well, why wait for 5? You just get the code interpreter plugin.
No. I agree. If you do a lot of prompt engineering, you'll be fine. Yeah. We try, but then they are not intelligent. They are human intelligent embedded in a language intelligent. And I will be quicker here. There is a lot of other weakness of GPT-4. First of all, it doesn't know the latest thing, like who is the president at that time, and then it cannot do calculation as we discussed. And it have real trouble of doing letter counting. Something where everyone can do, it cannot. But as Scott said, you can solve it by giving it some tools. For example, if it allows it to search, do calculation, do counting, then it knows how to use those tools after you tell him once. You don't need to fine tune it. Honestly, I don't really know what is the conclusion of this. Maybe is this an AGI? I would say it is intelligent but not human. I personally believe it is doing more than copy and paste, especially for area like coding. Although maybe some people still not agreeing. And when we obviously see it cannot do math in multiple ways. Especially it cannot prove any theorem. But for me, I think the real thought I have is it doesn't fully matter. It is incredibly useful. I'm using this daily for coding. For this is better than search engine, and I can use that for writing recommendation letter, writing grant proposal, grant report, or whatever. The GPT-4 English is way better than me. And more importantly, I think this is just the start of this exponential growth. Remember, one thing is scale matter a lot. This is 4 picture about a map of US made of sushi, of some image model of different scale. And you can see clearly there's some improvement there. And I think when I was in high school, I saw this picture in Wikipedia. At that time, I kind of think it's nonsense because I think the key difficulty of the intelligence should be what is the program? No one can, at that time, seems every program is just brute force. And how can you brute force a human brain? At least at that time, I think in that way. And this project happens in 2000. And amazingly, if you look at the prediction at this time, the forms is correct. And according to this part, we are getting close to human brain, maybe in 1 or 2 years. I don't know how accurate is this prediction 20 years ago, but this is kind of a crazy prediction. At that time, I would think this is just crazy, but now I still think it's crazy in a different way. So this is the first part of the talk. Anything? Oh, I think I have. Okay. So, after playing with the giant LLM, then what we talk about some small LLM, a baby LLM. So this is a paper called Textbook. All you need this is just some catchy title. Again, is John work with a team in Microsoft. What we're trying to solve is this simple question. Our goal is to get a one. I don't know what is the GPT-4 size, but you can search online to get the rumor. But our goal is to get a 1 billion size model for coding. This is maybe 100 or 1,000 or very large factor off from GPT-4. And we want to solve this type of question. This is a huge human eval benchmark from OpenAI. The benchmark is like this. You are given a definition of function with some description of what it does, and then output the code for you. So this is a code completion. Some question in the human eval is very simple, and some is very difficult. And as people from theoretical computer science, I really like making a giant table. So this is a giant table. This is progress on this benchmark after it is online. You can see something here. For example, you can see something like model size matter a lot. For a 300 million size model, you get 12%. 16 billion, you get 30%. So model size matter a lot for this model, for this problem. It is not a trivial task you can solve at that time with a small size model. And also, if you look at all the model below 10 billion size before this summer, the best result is 30-ish%. And so, and also you see here, so when you're talking about training, there is two parameters that is important. One is the size, one is how large is the data set. You can see many of them is 100 billion size. And the model we create is this, with 1 billion size, less than 10 billion data set, and our accuracy is more than 50%. And we also test any benchmark just to make sure we are not overfitting to one benchmark. And the result is still state of the art, except GPT-4 and 3.5. So at least it shows maybe we are doing something. So I will just discuss what we did. So to get a large language model, basically the only thing you need is a data set. So a standard data set is stack. It is a collection of source code from GitHub. It is 2 terabyte size. It is too large for our budget. We don't really have budget. We don't really have GPU to use to train a model. So and also if you look at the data set, it kind of nonsense. If you randomly sample a page from GitHub, this is what you get. Something it is not good as an example in the textbook. You just get a bunch of random stuff. But if you look at the data set more closely, maybe 1% of the data look like this. At least something seems to teaching you something, how to normalize a vector, then you do something, and how to compute a distance. It tells you something. So our first thinking is maybe we should just think LLM as a human. If we want to teach a human, we shouldn't just feed a random video from YouTube, but instead more like textbook. So what we do is we try to filter the GitHub according to its educational value. And nowadays, if you have a complicated NLP task you don't know how to do, then you can ask GPT-4. GPT-4 can classify whether a document have education value or not. Is pretty nice. Unfortunately, if you just use this to classify the whole stack on the Python, it will take 1 million. So it's not nice. So we do the most natural thing. We just label, say, 10,000 documents, and then use that to train a classifier, and then use the classifier to label the whole GitHub. Then it takes very small cost. And then we pick the top 20% of the GitHub. But when we look at the result, we see some of the topic doesn't really covered by the GitHub source code, and some topic is overrepresented. For example, it has so many Python websites, and yeah, it's just not a good distribution. So we asked GPT 3.5 to generate 1 billion size of textbook. The reason we picked 3.5 instead of 4 is because of budget. It's super expensive for GPT-4 to generate a bunch of textbook. And after our paper is done, we finally look at what we generated in those textbooks, and we found out they are full of mistakes. But whatever, we already done the training, and turns out the result is fine. So maybe if you use 4, then your result will be better, but you need a better budget. So those are what the textbook look like. For example, this one is teaching you about SVD, some tests and some code mixture. And then we call both the filtered GitHub and the textbook as the dataset code textbook. And this project is kind of inspired by the Tat Lee story done by Warren and Yuan Ji. They try to come up with a language model that is good at writing story, and they found out, turns out you just need 10 million size model to do that if your data is good enough.
I feel like the result in NLP that if you like train from a larger model makes your model good, has been like rediscovered again and again. But like you couldn't do this unless you had GPT 3.5.
Yeah, this is a tough question. It would be nice if I can do an experiment of downloading every Python textbook in the internet and then train a model, but they have real copyright issue. I suspect you will still get a good result, but I cannot test this.
There are some tests in the StarCoder paper where they do things like limit it to only popular repos or something.
Yeah, but if you look at those popular repos, there is still maybe more than 90% of the code is some repeated pattern. I mean, it's not.
I would take the negative on your bet. If you want to try that, I would take the negative that if you downloaded textbooks.
Yeah, but I could try privating textbook, but I think I cannot do that as a Microsoft employee.
You should join OpenAI. I think they'll let you do it.
Well, is that true? I think OpenAI cannot do that. They are getting lawsuit for this type of thing.
Sure, but I'm asking a science question, not a...
No. Then I believe it will work.
Okay.
But if you're academic, you can do this. It's just few $1,000s, and there is some websites containing every textbook in the world. Yeah. In some Russia websites, you can try.
Okay.
I cannot.
Okay, let's do it.
I try to go to those websites. It's blocked by Microsoft Internet.
But do you think my hypothesis is wrong, that you're just learning to act like GPT 3.5?
Yeah, no, I understand what you say, but I don't know.
I mean, it's a very interesting question, right? If you read a textbook and you train the weights of your brain on the contents of the textbook, and then you use that, is that pirating the book?
Yeah, this is also a legal question.
I mean, if you just use the 6 billion part of stat instead of the deep stuff, the performance will not work.
It is not done the slides. There is still another data set. This is not the most important part, so it's difficult to answer.
And getting the database from like code forces or programming website where there's like prompt and then like you can get the same.
Yeah, we did that experiment, but we realized it doesn't help because turns out 5% of GitHub is those things, so it is already repeated. And so this is not the whole story. Honestly, I don't know why the result model is good, but this is not the whole story. So remember, around that time, the best 10 billion size model is around this accuracy. So we are already pretty good at that time with just a bunch of textbook. And also again, scales matter. 300 million versus 1 billion, you see a large difference. And then, but then you can think we are just trying to train an LLM as is a human. The ideal thing is we intellectually talking with the model for 10 decades, and then it will be better, but it is impossible. So what we do is, if a student with the textbook, what is the next thing is to do some exercise. So we give a bunch of exercise to the model. We give him roughly 1 million exercise. We are trying to overfit the human eval, so everything is a human eval format. And then this is what you get from the result. So you may ask, did we just accidentally generate some human eval question so it can solve the human eval? So we do a lot of testing. I'm not going through these slides, but we did some serious testing to make sure we're not cheating. And since even we decontaminate the data set, the model is still behave really good. But at the end, we found a very good test that I find it very funny. We realized the model, after doing the exercise, it can do something that does not appear in the exercise at all. For example, we look at all the exercise, there is no problem related to PyTorch and Pygame. So we can try asking it some question about those packages. And turns out amazingly, it can do better, much better. I'm not going over details of those examples, but you have some long insertion of, you have the game, some ball moving around, and then something, and then ask it to generate. And this is our final model. This is before seeing the exercise, and you can see after seeing the exercise, you can solve those problems.
But these libraries did appear in the 6 billion tokens.
It appears in the GitHub, but it doesn't appear in the exercise. It's just kind of funny why after doing exercise, it organizes knowledge to something has nothing to do with exercise, somehow seems. Or another way to explain is maybe the model is just better at insertion following. It could be the another reason. Maybe it already know everything. It just don't know you need to follow the insertion. That could be the another reason. And then the most funny example we have is this. We do some chat with the model. Student, I have Python PyPod. I want to increase the resolution and rotate the image. And then the model is somehow able to answer it nicely after doing those exercises. This has a different mode. The exercise database is just question and answer in a particular format, and turns out it can do chat better after doing exercise. And we really don't have good explanation of that. But yeah, so our conclusion is, it seems it is possible to get a good small scale model for a narrow topic. And even for pre-training, low cost is possible, like a few $1,000s. Yeah, so during the project, one main theory question we want to answer but don't know how to answer is this. We have the internet. How can we tell which part of the internet is good and which is bad? Beyond just some heuristic, like asking GPT-4. And also, what is the good schedule of teaching the model? Is it better to show him some textbook and show him some exercise, or what is the ordering? When we are training the model, there is many people telling us the best way to train a model is first start with the internet with those NLP data, and then train the coding part. And in our paper, we didn't do anything. We just give him the data set and train it, and it worked well. And we tried different schedules. Seems it doesn't matter too much. But what type of, yeah, I guess more generally, what can we talk about the science of data for LLM? Yeah, that's it. Thank you.
Thank you for the great talk. would you like to comment on the stability of the results? Like even for the math, seems different people may come up with different answers, and sometimes the prompt may change a lot or may not. So like when you work on those two projects, how do you find that the sensitivity of prompts or just different temperatures affect the results?
So for GPT-4 one, I think when the model is good at something, then it is very robust under the prompt. But for a topic like math, it doesn't really know math, so it sometimes accidentally get the correct answer, or maybe that is just too trivial, turns out. Otherwise, it's just not robust because it cannot do. But for our model isn't good. Our model, if the problem is slightly more complicated, it cannot solve.
For the like web, you showed with different version of Unicode on everyday tracking. It seems they are not consistent in terms of the shape of Unicode.
Oh yeah, no. The public GPT-4 cannot do unicorn. I would just view in this way.
Yeah. So you said it doesn't really quite matter for experiments how you present the data such as when we teach a subject, you start from the simplest stuff first and then more complex and so on. So have you done any experiments where you present the data in that order?
Very interested in this. They look at mathematics being arithmetic or maybe something more sophisticated. But what about physics derivations? You go to physics class, they have exercises. They describe a situation and ask you, has that been worked on? Do you know?
I don't know any physics.
I mean, Ernie Davis and I just did it. We gave a bunch of physics problems. It can often do well at high school or undergrad level physics problems.
Yeah.
Not always, but yeah, you can look at our examples if you like.
Yeah.
So some of the
So there's more
evaluations
abstraction. What?
some evaluations have those too. High school physics, science, MMLU has.
Isn't that really uninteresting at this point? Because like all of that high school math, physics, chemistry, there are web pages that give the answers to every question.
Well, it depends.
I mean,
I had kids study physics in Israel and physics in the States. In the States, they give the questions are the same as. Not everywhere. The physics part is because it's abstract. There's an abstraction to understand.
So I mean.
I'm not very familiar with Hebrew physics questions, but I find with English ones these days, you look them up, you don't have to think, the answer is sitting on a web page. And so it's a very dubious test of general intelligence, in my opinion. Can I ask a question about that topic? I mean, for the sparks of general intelligence, I mean, in some sense, it seems that, a fairly random bunch of tasks, right? I mean, drawing a unicorn in ticks. It's kind of cute, and it shows that it's got some amazing competence from examples of bizarre skill, but it doesn't actually seem very close to general intelligence. I mean, you know, are there kind of tasks that are much closer to a general intelligence task that would make more sense to be exploring? And I think that they have to be tasks that have a novelty that you can create very different things. I mean, to throw one out there, Stanford colleague Mike Genezareth is like this general game playing framework where you sort of specify a set of rules for a new game that no one has seen before, and you work out whether the computer can learn a good strategy to play it. I mean, that sort of feels to me actually more like a test of general intelligence.
Yeah, we did a game playing, some experiment related to game playing in the paper, and I think it. So a few years ago, there is some standard benchmark on RL on some test-based game. So what we did is we fit those games to the AI to see if it can play, and in general it can play-ish, but if it make a mistake, it can correct a few times, and after that it starts repeating itself. So it can learn 1 or 2 steps, but not very long scale.
Yeah, I had a more, sorry, I don't know who you're calling. I had a more general question. I didn't catch in the paper that you'd set the temperature to 0. Was that true for like all the experiments in that paper? But the reason I'm asking is that it looks like the model is fairly well calibrated as a language model in terms of making good probabilistic predictions of the next token. So I would expect something that chose randomly would produce more typical results than something that always chose the most likely.
Yeah, I agree. It is calibrated. We do some testing on calibration and it works perfectly. But somehow, if we do temperature, okay. First of all, if the topic GPT-4 is good at, temperature usually doesn't matter too much. I guess temperature usually doesn't matter too much. Just we want it more deterministic.
Just one more comment about, like, you know, so us being scientists, we tend to think about intelligence as being able to do intelligent things given like new sorts of definitions or new sorts of environments. But these sorts of things are, you know, I mean, they're displaying a competence that is like pretty shocking. Most people would at least be very impressed. Let's not call it intelligence, but the sorts of experiments where you sort of say, okay, let me give you some new definitions, blah, blah, blah. Let me formulate some new sort of, imagine you're in some hypothetical setting, like these sorts of things, they are very different from what it's supposedly learning on. And these are like very different sorts of tasks that I think is like, we're very biased towards these. This is our competitive advantage in life, right? This is what we do for a living. But I don't think other people would call that intelligence, like outside of art. I just think, it's important. It's important that, you know, given some weird hypothetical setting.
So, the definition of intelligence is still hotly debated, but I think you have to have in the definition of intelligence that being able to cope with novel scenarios. Because otherwise, anything that
prompts, but these like bizarre hypothetical things, right? Like this is something that is.
Maybe one way to ask this question is there in this hotly debated topic of what's intelligence? Surely there's some classification of different levels of intelligence in the sense that you might say, well, memory is already an important element, but we solved that long ago with computers, or doing calculations. That of course was done a long time ago. But now, there's competence at these very basic tasks. Where does that fit? So is there sort of a accepted classification of a hierarchy of tasks and within which one can sort of say how well are we doing so far and what remains to be done?
I mean, these anthropologists tried to do this a century ago. It's an embarrassing effect, but there was some example where some anthropologist goes to some place, blah, 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 and says, okay, hypothetical. Let's suppose in some town, all of the dogs are red. Okay, suppose John lives in this town, and John has a dog. What color is John's dog? The person says, I don't know, go ask John. And the person wasn't an idiot. It was just like this hypothetical stuff isn't something they encounter, and that's it. But anyway.
Well, I think those claims are very controversial, but I agree there have been claims of things like counterfactuals as being this more advanced form of intelligence. I don't think there's actually any well-accepted and well-based hierarchy, not that I'm aware of.
I mean, maybe the simplest hierarchy you could say in most STEM fields, it's in high school or undergrad, and it's not in grad school yet. Like we have this, hierarchy that we, emergently that we create, and in order to, teach these things, right? And it's, judged by the very highest standard of being able to, deal with, completely novel situations and invent new concepts, right? It's falls short, but it's it is usually able to do under high school or undergrad level word problems. So I remember like 20 years ago, like back when these were all just philosophical thought experiments, right? Like there was the way people put the question was, suppose that you could pass the Turing test by just having a gargantuan lookup table that just cached the answers to all possible questions, right? Would that count? Would that be intelligence, right? And it seems like a more modern version of that question could be like, suppose that you've trained on all the undergrad physics problems on the internet, right? And then it can solve a new physics problem, and you're going to say that it's doing that just because of all the things that it's already seen. But if human imagination does not suffice to invent a new undergrad physics problem that it can't solve, right? Then, is this training on everything on the internet, was that just a valid way of getting the knowledge that it needed?
So I think it's very complicated. I mean, I think actually part of what's become clear is that memory and pattern matching is much more important to human and other creatures' intelligence than anybody used to realize. So, we shouldn't underestimate the amount of human intelligence as well that is memory and pattern matching. So I agree with that, but clearly.
I'm nodding because I've heard people say things like this, and it just,
I mean, it's what we knew very well in high school, and then we forgot.
Yeah, no. I'm just, I'm pattern matching what people are saying here.
Yes, ma'am.
I think one of the difficulties with math science reasoning in general is for going to higher levels, like graduate and non-research level, is just being able to algorithmically generate data sets for evaluation and also potentially for training. And if we had access to, we could generate training data sets in this way, then we could build pretty good, much better models. More complicated tasks, and so I'm kind of reminded of it seems like the things that we can algorithmically generate ourselves in terms of math problems, physics problems, have a certain simplicity to them, and these more complicated research level, say math, physics problems, we are not able to easily algorithmically generate, and this is maybe one of the limitations for evaluation.
Last couple of comments or questions?
No, I just want to say that the degrees of novelty and I gave this recent query. So you are in 2060 and teenager texting. What kind of abbreviations would you be using? Give a list of 10 abbreviations, but can you guess the first one? The first one is NAR. Not a robot. Kind of novelty.
So since you trained this small model on a narrow topic and it did seem to do very well, do you think training on such narrow topics can allow certain abilities like planning to emerge that a generalist cannot?
Yeah, personally, I believe you don't need a very giant model to do those planning or those abstract exchange. I think the real problem is, can we create a data set that contains those skills? And that seems very difficult.
Okay. How much, like when you add planning to the prompt, how much does it increase results? Because what I'm thinking is if you have a kind of, you ask the prompt and then there's a middle step where it can basically from your prompt figure out which topic you're talking about, like math, maybe politics, such an algorithm or some procedure has to follow, and inject that back into the prompt. And it does that like every time, and that could be a smaller model in the middle. I think you can introduce like for every single prompt an algorithm it should follow, and it can like dynamically make it, and then hopefully that can actually improve the results a lot better. That's kind of what we're experimenting.
Yes.
Maybe, I don't know, this is just a informal, non-scientific question, but you refer to the GPT-4 as he?
No, I sometimes refer my wife to he also. Because in Chinese there is no he or she.
Okay, yeah, I was just wondering, because like, you know, you have
No, there is no reason.
right? So it's a she.
Okay, so shall we break for coffee and we'll come back at 11. Thank you.
So excited. It was like the basis of